All right, so we are doing section 5.5, which is direct or inverse variation. Um, Now, we're going to start off with direct variation. Now, let me explain to you guys the difference between direct and inverse. So, like, for direct variation, more equals more, or less equals less. Okay, and just to give you some basic ideas of what this kind of means, um, when it comes to more equals more, meaning the more money I spend on gas, the more gas my car has, right? So that's a more relationship, okay? So, or you could say, uh, the less money I spend, the, I guess, yeah, the less food I eat, right? That's a less, right? The less money I spend, the less clothes I have, right? That's a less. Okay? So, with direct variation, the more you do of one thing, the more occurs for something else. The more miles I run, the more tired I am, right? So that's what direct variation. One thing affects the other directly in a positive or negative way, both of them. Okay, so it's either more, or less. Okay, now I know that might sound kind of weird, but don't worry, the formulas and everything, very easy to do. So here we go. Let me show you guys the formula for direct variation. It looks like this: y over x equals k. Both of these formulas literally just have three letters: y, x, and k. All right, but they look a little different. Um, but direct variation, y over x equals k. Now, k, we call it the constant of proportionality. Okay, so k is the constant of proportionality. All right, constant of proportionality. A lot of times we'll just call it the constant. All right, and if you ever want to try to figure out if a certain equation they give you is either an inverse or a direct variation, you need to isolate the constant. In other words, solve for k. If k is 8, then solve for 8. If k is 12, then solve for 12. But let me put that little hint right there, just right here. Isolate the constant. Okay. So whenever they're asking you, like, is this a direct variation or an inverse variation? Sometimes you might see them say like a linear equation or joint variation, stuff like that. We're not doing any one of those. We're just doing direct and inverse. Um, but if you have to figure it out, you got to solve for your constant. Okay, whatever your constant is. All right, leave the constant all by itself, throw all the other letters to the other side, and if it ends up as a fraction, then it's going to be direct variation. If it ends up as a multiplication, which we'll do right now, it's inverse variation. Okay? So there's direct variation as a formula. Now, inverse variation looks like this: xy equals k. So very easy formulas to memorize. Yeah. So very easy formulas to memorize. Xy equals to k. Just realized that's weird. Now, k is still called the constant of proportionality. Let me write that down here. So this is still the constant of proportionality. And again, if you want to solve to see if the formula you're given is an actual inverse variation, you are going to isolate the constant. That's basically what happened to this formula, is they isolated the constant. That's how they got this formula. They got k by itself. Okay? So that's what the formula looks like once you solve for k. So we're going to go over 5 examples. 2 of them will be pretty easy. The next 2 will be what it's going to look like on your quiz. And then the last one are going to be some word problems that only pop up on your homework but not on your quiz. Okay? And a lot of times people are scared that the word problems are really difficult. They aren't. You just need to assign letters. So, we'll talk about that when we get there. but it's pretty easy. So here's example 1. Okay? Is this an inverse variation? Okay, so first example, and again, these are homework problems, so you'll see stuff like this in your homework. Is this an inverse variation? So remember, the inverse variation formula is xy equal to k, right? Where k is just a constant, a number. Does this represent something that looks like that? Xy equals to a number?
Yeah.
Yeah, so you're just going to write yes. Or on your homework, you'll just choose yes. Or maybe it's going to say, instead of is this an inverse variation, it might say what kind of variation is it? And then multiple choice, you'll just choose inverse. Okay? So, because I know on the homework, I think it's all multiple choice. So, is this an inverse variation? Yes. Why? Because it looks like xy equals k. So, that's why it's an inverse variation. Now, number 2 says, what kind of variation is this? Well, we got to solve for it, but it would be direct, right? If you're going to want to try to make sure it is, we have y equal to 6x. Remember, in order to figure out the formula, I mean, you can see it in your head too, but we want to isolate the constant, which is 6. So let me divide by x. And when I divide by x, I get y over x equals 6, which would be my k value, bless you. Okay, so that would be my k value there. So y over x equals to 6. That is a direct variation, right? So this is direct variation. So far, seem kind of easy. You'll have a couple, like 4 or 5 questions like this, okay, where you're just kind of judging based on what they gave you, what equation does it look like? A direct variation equation or an inverse variation equation? All right? Now, aside from that, what you're going to be doing is eventually doing some quiz problems that look like this. Okay? Now, I know it looks like, wow, what the heck is this? But they're very easy. You're going to basically take them in 3 parts. Okay, the commas separate part 1, 2, and 3. Okay, so go ahead and take some time to write that down. I'm just going to pause it while you guys do that. All right, so example number 3 says, given that y varies inversely with x, if x equals 7 and y equals 4, what is y when x equals 2? So the very first thing you guys have to do is recognize what kind of variation we're using. Now they mentioned inversely. So if this is an inverse variation, then I'm going to use this formula. But I'm going to write it twice. The first time, the formula on the left, I'm going to have to solve for k. You will always solve for k first. Okay? So you're always going to solve for k. Then you'll solve for whatever they want on the second equation. Okay? So here we go. The first part of the problem we've taken care of. Okay, inverse variation. I wrote it twice. There you go. Second part says if x is 7 and y is 4. So let me write that down. X is 7, y is 4. Well, that means that k has to be 28. That's pretty easy, right? Not that hard. Now get this and plug it into the other equation. So I'm going to put a 28 right there for k. And then I'm going to read the last part of this problem. What is y when x is 2? 2y. So if I divide both sides by 2, I get that y is equal to 14. And you're done. Notice it's not a lot of work. You might need calculators here and there because maybe the numbers don't make perfect sense in terms of dividing. You know, if you got to divide a 5 by 4.
Wait, how'd you get the 2?
The 2. Oh, they tell me the last part after the last comma it says what is y when x is 2, right? So yeah. So but yeah, if they tell you what's 5 over 4, you might want to do it on your calculator, or if you know it's 1.25, that's fine too. But you might have to use calculator here and there for little calculations, but nothing crazy. And the work is pretty much like this is pretty much what you're going to see for example 3, example 4, even the big word problems, they'll pretty much have just this much work. They don't require a lot more. Okay? So let me give you example number 4. I'm going to pause the video for about 2 minutes while you guys write it down. All right, so given that y varies directly with x, so direct variation is y over x equals k. And I'm going to write it down twice. Remember, the first time you use it to solve for k. The second time, the second equation is used to solve for x or y, whichever one they want you to solve for. So here we go. Y varies directly with x. So next part, if x is negative 15 when y is 9. So 9 over negative 15 is equal to k. So if I just, well, 9 over 15 is the same as 3 over 5. So that'd be negative 0.6. So this comes out to negative 0.6. That's going to be your k value. Okay? And then you're going to take that k value and you're going to put it in the second equation. So that's going to be negative 0.6. And then y over x. Let's read the last part. After the last comma, it says, what is y when x is 21? So y when x is 21. So if I multiply 21 times negative 0.6, I get a negative 12.6. And there's my answer. So, I mean, hopefully you guys see what I mean. Like, yeah, they're word problems, but they're not that bad. You just write the equation twice, find k the first time, then solve for whatever letter they want at the end. So your quiz coming up on Wednesday will have 2 questions like example 3 and 4. One will be inverse, one will be direct, okay? So make sure that you can do both. And they're going to look like this. They're going to be set up like this. Now in your homework, you're going to have some other problems that don't look like this, but you still require the same amount of work, and those problems look like that. So I'm going to give you a couple minutes to write this down. All right, so for example number 5, the volume V of a gas varies inversely as its pressure P. If V is equal to 80 cubic centimeters when P is 2,000 millimeters of mercury, find V when P is equal to 320 millimeters of mercury. Okay, so what I'm going to do first is I'm going to reassign my variables. Okay, I know that it says it varies inversely. So inverse variation looks like this. xy equals k, xy equals k. So I'm writing that down twice. Now, since the letter x comes before the letter y in the alphabet, and the letter v happens to show up first in this problem, then I'm just going to say, let's let v equal to x. And we'll let p equal to y. And I'm just going to go through the whole problem and rewrite those little letters next to each variable. So v is x, p is y, v is x, p is y. And there you go. I just made this problem a lot easier for me because now I can assign the letters based on x and y like I've been used to. So we did the first part, right? The first sentence, the inversely, we wrote the 2 equations. The next part comes in the next part of the second sentence. It says, if V is 80 cubic centimeters when P is 2,000, and I put if X is 80 cubic centimeters when P is 2,000. So P is Y. So 80 for X, 2,000 for Y. That's 160,000 for K. Notice I just rewrote the letters, that's all. Okay? And then it just becomes a normal problem. All right, last part. Find V, in other words, find X, when P, which is Y, is 320 millimeters of mercury. So Y is 320. By the way, my X is 160,000 here. So Y is 320 X. Because I have to find volume, but X is my volume. So if I divide both sides by 320, X is, if I remember correctly. Okay, I was going to say, is that 500? So 500. Awesome. Now, remember, X represents my volume, and the volume units are in cubic centimeters, so I'm going to write cubic centimeters. And that's it. I'm done. Okay? So this isn't terrible. Like I said, it might look like it when you're doing the homework because you're like, oh, all these word problems. Just reassign the letters, and you should be okay. All right? So I'll give you guys the homework right now.